In today's activity, what we're going to talk about is why things fall over. So in this case, why, let's say, buildings fall over. So what you're going to need is you're going to need a ruler, and you're going to need some building blocks. So that's either Lego blocks or Mega blocks or whatever blocks you might have lying around. You're going to need two structures. So I have 10 of these size blocks, but you'll need at least one that's very tall. Now, what we're going to try and do is I've built one structure that's 10 blocks tall and 1 block wide, and another structure that's 5 blocks high and 2 blocks wide. And what we're going to do is the ruler is just to stop, so we're going to tilt them over and see when they fall over. And the ruler is here to stop these objects moving when you want them to move in this direction, to tip over rather than just push it on the table. So I'm going to just show it to you at a different angle to make it easier to see. So before we do this, we might get you to predict what you think is going to happen. So do you think the taller building will fall over before the shorter, thicker building? Now we're ready to do the test on the structures. So what we're going to do is we're going to hold down the ruler and then push both of them and try and keep them at the same angle and see which one goes first. So we have a small push. So I hope you can see there that the tall one fell over much faster than the wide one. Now, just to show you why that's the case, you need to think about the center of mass of both of these objects. So I've marked the center of mass of both of these objects with these little squares. And the center of mass of this object is because it's 5 above and 5 below, so it's kind of in the center of the thing, but with 5 above and 5 below. In this case, there's 4 here and 4 below, and then I'm in the middle of this middle one. Now, so when the center of mass of the object, which is here, is this side of the contact point, which is the point which is contacting the ground. In this case, it's contacting the ground over the whole of this. But when you start to push it up here, that's the contact point. That's the only point left on the ground. So now, when you push it, if this center of mass is this side of the contact point, it will always come back down to this side. But if you push it a little bit further and the center of mass is this side of the contact point, it will fall this way. Now you can see in the two different structures that the center of mass of this one is lower than that one. And that's why it's far more stable, because it takes a lot more of a push to get this center of mass to go the other side of the contact point. Whereas in this other structure, when you push on it, the center of mass is very high. So if you give it even a small push, that puts the center of mass at this side of the contact point, and it falls over. You can do another activity with this, is if you take the wide structure and then show that if you make it into different shapes, you can see which one's balanced. So you can see this one, which should have a low center of mass should be down here. It takes a lot to push that over, whereas if you take it and put it on top and try the exact same thing, the smallest little tip now will make that go over. The smallest tip, that's even more unstable than this tall structure, because most of the weight is at the top.